The quadrilateral ABCD is a trapezium in which AB and DC are parallel. Okay, so let's say I draw out a random trapezium. Okay, so they say AB and DC are parallel. Okay, with respect to the origin O, the position vector of A, B, and C are given by OA, OB, and OC. So given that DC equal to 3AB, DC equal to 3AB, find the position vector of D. Okay, so we do like this. DC equal to 3AB. Okay, so we have to know that DC is actually DO plus OC, and then AB is actually AO plus OB. So imagine from A you go back to origin, from origin you go back to B. So that is a long journey for AB. Okay? So A to O, then O to B. We end up with AB. DC, the long journey is D to O, then O to C. So we make it in that way. DO is actually negative OD. Negative OD. AO is actually negative OA. Okay, now we substitute. Negative OD remain as unknown. OC, if I will change the OC to a column vector. Column vector, the convenient part is no need to write no need to write this I, this J, and this K. So which is faster. No need to write that much of thing. 2 minus 3. But this is not compulsory, it's optional. If you want to use back 2I plus 2J minus 3K, just go ahead. Okay, so 3 minus OA minus, okay, OA is here, minus 1, 2, 3 plus OB. OB I change to column vector. 1, 3, 1. Okay, now I solve the equation. So I do right hand side first. 3. Okay, the minus I bring in. 1 minus 2, 3. 1, 3, 1. 3. Okay, now I add up the two column vector here. 1 plus 1 is 2. This one minus 2 plus 3 is 1. 3 plus 1 is 4. Okay, then I get times 3. I get 6, 3, 12. Okay, this is minus OD. Imagine this 2 minus 3 I bring to the left. I minus 2 minus 3. Then I will get 4, 1, 12 minus 3 is 15. Okay, so when I get minus OD equal to 4, 1, 15, then OD is negative 4, negative 1, negative 15. So where I have to put it back in the IJK forms, because the question is put in that way. Yeah. So there is a mistake. The mistake is here. This should be negative 3, negative 3, 1, negative 2, negative 3, negative 3 plus 1. This is negative 2. Negative 2 times 3 times 3, negative 6, negative 6, minus 3, negative 3. Okay, negative 3. Then this is positive 3, positive 3. Okay, this is 3, positive 3k, positive 3k. Okay, now let's move on. B. State a vector equation for the line through A and B. Okay, so vector equation for line, the formula is R equal to A plus constant direction. So this is the formula for vector equation of line. So where A is a position vector on the line, B is the direction. Okay, direction. So our line is AB, and we already have AB from this working. AB, you can see this part. Okay, so this is AB. 2, 1, minus 2. 2, 1, minus 2 is AB. Okay, so that is the direction. And then positions, you can put either point A or point B. So normally we will put the first point. If they say AB, then we put the first point. If you put the second point, it's okay, nothing wrong. Okay, I put the first point. So I'm going to put OA. So R equal to OA. So OA is this one, minus 1I plus 2J plus 3K. So I just put it there. Minus I plus 2J plus 3K. That's position. Plus T multiply with the direction. So the direction is, like what I said, is just what we found just now. 2I plus J minus 2K. Okay, so this is the vector equation of the line. Okay, now C. Find the distance between the parallel sides and hence find the area of the trapezium. Okay, so imagine your trapezium A, B, C, D. So this is the trapezium just now. So we want to find the distance between the parallel sides. So meaning that we have to find this distance. For example, this one, this distance. Okay, so in order to find this distance, let's see the information just now. We already know vector AB. So I write down the information available first. AB we have found, which is 2, 1, minus 4. Okay, we also found C. Okay, we don't have CD yet. Okay, so let's say I have AB. Okay, AB. I have OD. OD minus 4 minus 1, 3. Okay, so I have OC also. OC is 2, 2 minus 3. Okay, so if you want to find the distance, the distance between the two parallel lines, so what we can do is, since I know AB, finding CD is not a problem also. CD. Okay, CD. I find CD first. I'm planning to use scalar product later. So Okay, I find CD first. CD is CO plus OD. Okay, CO is negative of OC, so negative 2, positive 3. OD is minus 4, minus 1, 3. Then I get minus 6, minus 3, 6. Okay, this is CD. So once you get CD, and we know that we have, okay, let's see first. From part B, we have a vector equation of the line AB. Vector equation of the line AB. Okay, so okay, I make use of that equation. So from part B, we have the vector equation. The vector equation you can use in this way one. You see the vector equation I write down first. From B, we have R equal to minus 1, 2, 3 plus T 2, 1 minus 2. Okay, this is vector equation from B. How we use it? We can use it to represent any point on the line AB. Any point on the line AB. Okay, so let's say what am I trying to do now is, since I have this vector equation of line, I'm going to shift my blue line to somewhere else which will help me in this sense. Let's say okay, I run away the blue line, I shift it into another position. So I shift it here, I extend my line, I shift it here. It's actually same, so just now I pull it here, the distance is D. Now I pull it at the side, the distance is still the same one, if you can imagine. Okay, so the advantage of doing this is this point, right? Let's say I call this point E. This point E, because it's on the same straight line. Okay, it's on the same straight line. So this point E, I can take this as my position vector. Okay, I can take this. Any point on the line AB, even though you extend it, it's still okay. Any point on the line AB, you can just take their position vector as the right hand side of the vector equation. Okay, so I write down first the short note. Since E lies on AB, okay, then I can say that my OE can take the right hand side of this form. So which is minus 1 plus 2t 2 plus t 3 minus 2t. Okay, this is my OE. Then after that, with OE, I can find out CE. I can find out CE. Okay, CE. I want to find out CE. After that, I can find the magnitude. The magnitude will be the distance that we are looking for. Okay, I find out CE first. CE. CE is CO plus OE. Okay, so we know CO is the opposite vector of OC. So I just put negative sign for my OC. Negative 2, and positive 3. OE will be this vector that I found just now. I just write back. Okay, then I simplify. I get minus 3 plus 2t. Minus 2 plus 2 gone. T remain. 3 plus 3, 6 minus 2t. Okay, I get my CE now. So when you get CE, right, look at the diagram and you have to understand that CE is actually this one. And it is perpendicular with this one. This one we know the vector already. The vector is 2, 1, minus 2. As you know, 2, 1, minus 2 is vector AB. So AB is like this way. CE is like this way, where they are perpendicular to each other. Okay, so I bring down this information. This is AB. AB is 2, 1, minus 2. They are perpendicular. So I write down, since CE perpendicular to AB, then I use scalar product now. CE dot AB. You know, basically the scalar product formula is like this one. CE modulus AB modulus cos theta, cos theta. The formula is like this. But the thing is, we can cut short a lot because of perpendicular. Perpendicular means the angle is 90 degree. And cos 90 is 0. Yeah, cos 90 is 0. So everything on the right hand side, everything on the right hand side becomes 0 already. Because cos 90 is 0. So we just need to care about left hand side as right hand side becomes 0. Okay, so let's work it out. We want to find t basically. Multiply with AB. AB, where is AB? Okay, AB is here. 2, 1, minus 2 equal to 0. Okay, so how we do scalar product? If you still remember, it is going to be like this. You take the first row, multiply with the first row, minus 6 plus 4t, then end up with, now we take second row, multiply each other, t times 1, we get t, end up with, we take the third row and multiply each other, then we get negative 12 plus 40 equal to right hand side 0. Okay, then we find t. We can solve this easily and find t. 4t plus t plus 4t is 90. 90 minus 18. Minus 18, I shift to the right, positive 18. T equal to 2. Okay, so when I get t equal to 2, what should I do now? Okay, let's see. You can see it in this way. We want to find this perpendicular distance. This perpendicular distance is CE. CE is here. This is the vector of CE. I know 2 already. I can put 2 here, then I know the vector of CE. Then I find the magnitude. That magnitude represents the length of this perpendicular distance. Okay, so now let's do it. CE, I put 2 inside. So I substitute into here, minus 3 plus 2, 2. Minus 3 plus 2, 2. Okay, let's say I write down the working. 2, 2. And then 2. 6 minus 2, 2. Okay, then I will get CE equal to 1, 2, 2. So I get CE equal to 1, 2, 2. Then I find the magnitude. So the magnitude is basically you square every number and add them up and then square root. So I get 4 plus 4 plus 1, 9. Square root 9, 3. Okay, so that is the answer. This is the perpendicular distance. And after that, find the area of the trapezium. Find the area. Okay, so now we continue with the area. To find the area, first we have to add up the two parallel sides. Find the magnitude of the two parallel sides first. So, which is the magnitude of CD? CD, find the magnitude. So, we take this vector, we square them and add them up. Minus 6 square, minus 3 square, 6 square, square root. Okay, then let's see what value we get for this. This is 36 plus 9 plus 36 square root. Okay, we get 9. Okay, then after that, I find out the magnitude of AB, which is the length of AB. The length of AB, so since the vector is already found, which is here, 2, 1 minus 2, I just need to square and add them up first. 2 square, 1 square, minus 2 square, square root. So 4, 9, 3. Okay, this is 3. Okay, then I can get the area. 1 over 2. Add up the parallel sides. 3 plus 9. Multiply with the height. This is the height. Okay, this is the height. Let's say I just label it. This is the height. Multiply with height. Okay, then we get the area. This is 12 over 2, 6, 6, 9, 3, 18 units square.